regions in space where up to 2 electrons can be found. It's a region in space, or a volume, you can use the word volume, region in space where up to 2 electrons can be found. Now I'm going to write about 3 or 4 really crazy sounding sentences.
Dr.
Yeah.
Yes, mine's about sublevels. What was the sublevel again?
SPDF is a
Okay,
further
okay.
breakdown of the major level. Okay. And here are these crazy sentences. On an S sublevel, there is one S-type orbital. On a P sublevel, there are 3 P-type orbitals. On a D sublevel, there are 5 D-type orbitals. And this will be the last one. On an F sublevel. Does anybody see a pattern?
Yeah.
How many?
One next.
Okay, there's 1, 3, 5. What's next? 7. There are 7 F-type orbitals. Okay, now let's first think about shapes of these orbitals. But do you see, you get a feel for how this is all going to fit together. Each orbital can hold 2 electrons max. Okay, when we were on an S sublevel, we learned that 2 electrons would fit there. Well, there's just 1 orbital. Okay, when you're on a P orbitals come in sets of 3. Well, what did we learn before? The P sublevel can hold a total of 6. So 3 times 2 is the 6. See, as we learn more about the subdivisions, we see how it fits together pretty well. Then, on a D, we learned a D sublevel could hold 10, so it must have 5 sublevels, because, or not sublevels, orbitals, because each orbital can hold 2. So 5 times 2 gives us the 10 total for a D sublevel. Now let's talk shapes here. If we have an S orbital, the shape of it, we draw it like that, it's a sphere. Okay, so here's how you can think. And again, it's kind of simplistic thinking. Okay, if I have a 1s orbital, okay, first of all, in the middle of the atom is this nucleus. And of course, atoms are 3-dimensional, so here we've got the nucleus is in dead center. It's this little teeny tiny sphere in the center. The 1s sublevel has an s orbital. An s orbital is a sphere. Now, we do not believe the electron is like going around the nucleus on the surface of the sphere. That's old thinking, like over 100 years old now. What we think is there's just a high probability that the electron will be found, or 2, up to 2, will be found somewhere within this volume. You can think of it like a room for the electrons. Okay, if you're on the second major level, you're in a 2s sublevel, you got another s orbital, it's just a bigger sphere. 3s, bigger sphere. And again, it's a volume in space where there's a high probability of finding up to 2 electrons. It's not the surface we're interested in, it's just the volume it could be found in. Okay? All right, then let's move on to the P's. When we have a P orbital, usually we draw them this way. Dumbbell shaped. But what we found is we come in sets of 3 of these, and I'll show you a picture in the book that can do a much better job than I can. We call this the x-axis. There's a p orbital along the x-axis, and those should be symmetrical. That's just my lack of talent drawing. So this would be 1 p orbital. Think of it as a volume. Of course, this is 3-dimensional. In fact, I even have some models. Okay, let's go back. If we want it in 3 dimension, that would be an s orbital. That's a sphere. The nucleus would be dead center of this thing, tiny, 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 because most of your volume is coming from where the electrons are. Okay, 2 electrons would be found somewhere in this volume. Or there's, let me just put it, there's a high probability. It's like on 10 a.m., Tuesday, Thursday mornings, there is a high probability you will be found in this room. Now, you're not always here, but you're here most of the time, and there's probably a slightly higher probability I will be in this room. Okay, so, but if it were Saturday night at midnight, there would be, I would bet, 0 probability of you being in this room. But still, there's a finite chance you're weird and you broke into the building and you're in your state. Okay, so your s orbitals are spherical shape. And so a 2s would just be a bigger sphere. Now, the p's. We will pretend, and this is way out of scale, but this is the nucleus. Okay, this lobe and this lobe together is our dumbbell. Okay, if I've got the x-axis this way. This is how it would be oriented in space. So 2 electrons, up to 2, there's a high probability could be found in this lobe, maybe on the surface, maybe buried down in, or in this lobe. They could both be in this lobe, or both be in that lobe, or one in each. It's just a probability of finding it in a volume shaped like this. Let me go back up to here. Let me call this the y-axis and this the z-axis. So, we have another one. And we could even name these things. This one would be called the p sub x orbital. This would be called the p sub z. And then our third one is found coming out this way, going back that way, and then my picture gets real messy, and that's the p sub y. Now let's look at the models and see if we can put this together. Okay. If it's this direction, based on that, okay, this would be the p sub x. That would be one of them. Okay, there would be not just this horizontal one, there would be a vertical one, and with my drawing, that's the p sub z. And then there's an in and out one, and that's the p sub y. They're found at 90 degrees to each other. Why? Who knows? But that's just what's been found. So, if we can make this thing hold together, okay, there would be 2 of them. And then, got to find one. These things are older than you guys are, I'm sure. Because I was using these things here at this school 30 years ago. Okay. There you have it in 3D. These are old enough to vote or to drink.
These are not like the shape. You're saying that this is the way it's traveling.
No, I'm not saying it's the way it's traveling. These are weird shaped bedrooms. Okay? It's a volume in space. We do not think, and that's a good point, it's no longer thought that if you took 1p orbital, the electron is running a figure-8 racetrack. No. It's just that. This up with the down lobes, that's 1p orbital, and 2 electrons could be found in it. Somewhere. Could be on the surface, could be down in, who knows. But there's a high probability that's its home, or their home, because 2 can be there. So here's one, and it'll hold. Here's another, the sideways one, and then the in and out. Okay, that could represent the 2p sub level. Could it represent the 1p sub level?
There's no one.
There is no 1p, so no. This could be the 2p. If you have a 3p, it simply looks like this, it's just bigger. Can you kind of get an appreciation of how complex the atom must be? Because here's the nucleus in the middle. You got an S sphere in there. You got a second one for the 2s, and then this superimposed on all of that, and then it's mind-boggling. Okay, let